What is going on, guys? Vlad here with SolusPLC.com, and welcome back to yet another instructions tutorial. So today we're going to be looking at two instructions within the compute/math subcategory, and as you can see on your screen, these are going to be the add and the subtract instructions. Commonly known as the ADD and SUB. So these instructions are going to be fairly straightforward from a mathematical standpoint. However, they do have a couple of nuances to them, so we're going to explore them and look at a couple of examples. So let's just dive into it. So in my first rung, all I have is the add instruction. So the add instruction, you will notice, is on the output side, which is on the right side of your ladder logic. This means that this instruction, if everything is true on the left side, will execute. Therefore, here I have three different dints. So in my source A, I have system dint 0, in my source B, I have system dint 1, and in the destination, I have system dint 2. So the instruction, all it does is essentially add this source A to source B, and then it stores it in the destination as the name would suggest. So here we have 100 stored in this dint. So 100 plus 46 is going to be 146. As I've mentioned before, this is an output instruction, and since there's nothing before at the beginning of this rung, it will always execute each and every scan of the PLC. Therefore, if I change this, for example, to 200, as you can see, the addition happens immediately and the number is updated in this system dint 2 as I change the system dint 0. Similarly, if I change system dint 1, that will take place immediately without any delay. Let's move on to the next rung. So subtract, just like the add, is an output instruction, and similarly you have a source A, source B, and a destination, and in this case all you're doing is subtracting source B from source A, or in other words, this 1000 minus 200, and then it's going to be equal to this 800. So fairly straightforward, nothing too complicated. The only thing that you of course need to remember is that everything needs to be true in order for this instruction to execute. And let's look at one example where this is the case. So in my rung number 2 right here, let me just scroll down a little bit. I have this system boolean 0, which is currently disabled through an XIC instruction, which leads to an add and a subtract instruction. So do remember that when you have output instructions in a series like so, it doesn't necessarily mean that the add instruction needs to be true before the subtract executes, but they both execute at the same time. So the only thing that needs to be true is the system boolean 0. Now the system boolean 0 is going to be toggled by me through Control T. You can also right click and go into this toggle bit option, but let's look at what's happening here first. So right now, as you can see, everything's of course executed. So let's reset both of these integers to 0. So as you can see, the system dint 8 and system dint 11 are 0, and nothing is happening. The addition and the subtraction are not taking place. As soon as I toggle this, however, these instructions do execute and allow the output to be calculated. And of course, as long as the bit remains energized, that is going to continuously happen. If I update my numbers, then as you will see, the integers or the dints will update automatically. However, if I de-energize, if I do make some changes to my values, they will remain the same. So you can create some very clever logic which would only update your values at a certain point in time. So that's just something to keep in mind with these instructions, because they do need to have a true input leading up to them in order to execute. Let's look at a slightly more complex example, which I have right here. So I have this system boolean 1, which leads to a timer, system timer 0 of 2000 milliseconds or 2 seconds in real time. And once this timer is done, I use an add instruction to add 5 to this system dint 12, and then I store that value in system dint 12. So there's a couple of things to notice. So first of all, I am storing the value in the same integer or double integer as I've added in the instruction. So that is definitely allowed. You can essentially create a way to increment the same integer as you would like. And the other thing is that this 5 is of course a constant. It is not stored in a in a tag, therefore you cannot simply modify it. So if I double click this 5, you will notice that I cannot modify it the same way as I can any other tag in my instructions. The only way to do that is if I, of course, edit the rung, and I can set this, for example, let's do a 10 instead of that 5. I can put a 10 in there, and I need to compile my logic. We are, of course, online with the PLC, so everything is live and working as expected. And I'll give you a second to kind of predict what this logic will do, but essentially let's get into the explanation. So as soon as this timer starts, it will start counting to 2 seconds. As soon as those 2 seconds will have elapsed, this done bit, as we've learned in the timer section, will energize. Once this bit is energized, it will add this 10 to this double integer 12, and will essentially increment it by 10, and the timer will reset itself. So in a sense, we are creating some kind of a counter system, which instead of counting by 1, as you remember, a normal counter, whenever it's energized, it will increment the value inside of the counter by 1. We are incrementing this counter, or this system, double integer 12 by 10. So this value, of course, can change, and you can adapt it to whatever you'd like. You can have a number of cases, and you can have, depending on how many you've counted, put that into your value. But essentially, this will increment every single time by a value of 10. And let's look at that in action. So once I enable this bit, our timer starts counting, and as you can see, every single time that the timer is completed, we increment this value by 10. And like I mentioned before, we can change this. Let's go back to, for example, a value of 7, recompile the program, and now we should be incrementing by a value of 7 instead of by a value of 10. So this makes it extremely versatile. You've essentially created a very simple program which mimics a counter through the use of a timer and an add instruction, as well as a couple of registers on your PLC. So this could be something that you can use in an interview. This could be a very simple basic interview question where on a whiteboard you create a counter by using a timer and an add instruction. So very, very useful to know that. And just as a summary, like I said, we've learned about add instructions, we've learned about subtract instructions in this video. All you need to know is essentially you're adding source A to source B and storing them in the destination. And on the subtract side, you're subtracting B from A and storing that in the destination. You can use integers, you can use double integers, you can use floats within these instructions, and they are output instructions. Therefore, they only execute when everything before them is absolutely true. So thank you guys for watching, and see you next time. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave them in the comment section below. And if you can spend 5 seconds of your time liking as well as sharing that video if you've enjoyed it, that would mean absolutely the world to me. And if you have any suggestions for the channel, what kind of hardware, software I should be covering, then make sure to leave that down there as well. See you next time. Take care. Bye.